let's check out the Swern oxidation without the template. So before we even add an alcohol, we're going to look at some of the reagents that we need. So we need a dimethyl sulfoxide, DMSO. These are two methyl groups. And I'm going to start by writing the resonance form of this. I'll leave off the carbons and hydrogens and just have a line to represent that. And this is a charge. So what I'm going to do now is add in to my DMSO, I'll add in some oxallyl chloride. So the DMSO now, in its charged separated state, has these lone pairs out on the oxygen, and we can use those to actually add to the carbonyl. So then we'll have an intermediate, and that would be step one. Let me just say, that'll be step one. So then we'll have an intermediate that looks, let's see, something like chlorine, oxygen's here with a negative charge, another oxygen that added, attached to it is the sulfur with a plus charge, and then the rest of the oxallyl chloride. So now, step two will be the return of electrons. So if the oxygen can come down, that will actually kick out a chlorine. So the result of that will be double bond O. There's the O to the sulfur, plus charge on the sulfur. Okay, so now we have, and we've lost the chloride out here, just kind of hanging out. So next step, let's add in an alcohol. The alcohol, I'll just pick cyclohexanol, and we'll have that with its pair of electrons add to the sulfur, and that will actually kick out this oxygen as a leaving group. So next step, we have an intermediate with the alcohol added to the sulfur. And this intermediate is kind of awkward because we're going to have two plus charges on next door to each other. So the other thing that I didn't mention is that alcohol has a hydrogen attached to that same carbon. So next step, we should probably take away that extra proton so that we don't have two charges next door to each other. So let's see, we've done step one here, the DMSO added to the oxallyl chloride. Step two was the collapse of our intermediate where chloride was lost. Step three, the alcohol added to the sulfur. And now this will be step four. We're going to use the lost, oops, I forgot to change color. O minus from oxallyl chloride. This is not oxallyl chloride anymore, but an acid derivative of that. So that will take the extra proton and return a pair of electrons to the oxygen. Okay, so next step. That leaves us with still an intermediate, oxygen attached to sulfur, plus charge on the sulfur. And then the last step, we're going to use triethylamine. So the nitrogen, 3 methyl groups on it. Sorry, triethylamine did we say? Trimethylamine should work. I'll make it triethylamine. There's a lone pair. And so now what that one will do is, it's a good base. That will remove this extra proton. This is unusual. We haven't seen this kind of proton removal very often. Those electrons will stay here to form a double bond with the oxygen. And then the electrons that were attached between the oxygen and the sulfur can go down to the sulfur now. So this should give us our oxidized carbon and the reduced sulfur, because all it has there are, I didn't put the lone pair that's been on there the whole time, but that is dimethyl sulfide. So that's the basics of the Swern oxidation. The other part that's here, but we didn't look at, is actually the collapse of this oxallyl chloride derivative. So I think we'll quickly do that. O minus, that's this material coming down from the arrow above. So basically it needs to collapse down. So I think that what we'll do is, well, we're going to lose electrons to this, and then those will go on to this carbon. So that process right there should give us carbon dioxide. And then we'll have C double bond O with a lone pair and a chlorine. I don't think that looks very stable, does it? So I suspect that what happens now is these electrons swing down and we lose chlorine. And so that will give us carbon monoxide, one lone pair on the oxygen, plus charge formally, minus charge on the carbon. So the total is 0, plus chloride. So that is all our products now. And then this, back up here, we had the triethylamine hydrochloride salt. And there was a chloride counterion to that from before.